part A, to determine the domain of a function, we only have one rule going on here. That's that when you have a natural log of something, that something has to be greater than 0. And we're in luck because if we subtract the 1 over, we have absolute value of x greater than -1. And it always is, because when you take an absolute value, you'll either get 0 or a positive number. And so this is always true. So our domain, we have no restrictions. It's -infinity to infinity. Now for part B, we need to look at the possible outputs. What is the range of f? And we have to think about the natural log. First of all, the natural log gives outputs of anything. It could go down to -infinity and up to positive infinity. However, that's only if anything can be plugged into the natural log. And what's being plugged into the natural log here is the absolute value of x plus 1. And so, first of all, the absolute value of x is always greater than or equal to 0. So the absolute value of x plus 1 is always greater than or equal to 1. And so now taking the natural log of that, the natural log of the absolute value of x plus 1 will be greater than or equal to the natural log of 1, which is 0. So our range, the output, is everything greater than or equal to 0. So from 0, inclusive, to infinity. And that's our range. For part C, the x-intercept of f is when the output is 0. So we take our function and set it equal to 0. 0 equals the natural log of absolute value of x plus 1. And then we can just solve for our x. So do e raised to both sides. We get 1 equals the absolute value of x plus 1. And then we subtract 1 from both sides. We get 0 equals the absolute value of x. So of course that means that x must equal 0. So that's our x-intercept. And now we will sketch our graph of f. And we'll do that right here. We'll start with just the regular natural log function. So y equals the natural log of x. We know what that looks like. And then we'll do some transformations. First thing we'll do is we'll take y equals the natural log of x plus 1. And that is a shift to the left of 1. So we now have an asymptote there at -1. And then we'll take our absolute value of the x. And when you take an absolute value of an inside, it takes your function and it takes all the things to the right of the y-axis, so that's this portion here, and it reflects it across the y-axis, so we get both portions there. So using my symmetry tool, I'll just kind of trace that portion. And that's what we get, the portion to the right of the axis, and then we reflect that across, and we get both of those. And there's our graph of f.